Good morning, everyone. I'm Jessica Therese R. Santiago, and I'm the leader of Group 1. Our topic is about weathering. So, what is weathering? Weathering. Weathering is the process of breakdown of the rocks at the Earth's surface by the action of water, ice, acids, salts, plants, animals, gravity, and changing temperatures. Para maintindihan ito, ang weathering daw po ay isang proseso ng pagkasira ng bato sa ibabaw ng lupa na sanhi ng tubig, yelo, asido, halaman, hayop, grabidad, at pagbabago ng temperatura. Example of weathering is a wind and water cause small pieces of rock to break off at the side of a mountain. And also, there are three types of weathering: physical weathering, chemical weathering, and biological weathering.
Physical weathering. Physical weathering is caused by the effects of changing temperatures on rocks, causing the rock to break apart. The process is sometimes assisted by water. It happens especially in places where there is little soil and few plants to grow, such as mountain regions, and hot deserts. It occurs either through repeated melting and freezing of water or through expansion and contraction of the surface layer of rock that are baked by the sun. So, physical weathering happens when rocks are fragmented into minor fragments while ensuring no alterations in their chemical makeup. The main cause behind physical weathering include spontaneous fluctuations in temperature like too high or too low heat or cold. There are three main types of physical weathering. Number one is abrasion. It occurs when rock surface is frequently exposed to water, wind, and gravity. So, the primary process in physical weathering is abrasion, and it is the process by which glass and other particles are reduced in size. Abrasion by water, ice, and wind processes loaded with sediment can have a tremendous cutting power to form gorges, ravines, and valleys around the world. Number two is freeze-thaw. It occurs when water continually seeps into cracks, freezes, and expands, eventually breaking the rock apart. It occurs in mountainous regions like the Alps or Snowdonia. So, it is a process of erosion that happens in cold area where ice forms. A crack in a rock can fill the water which then freezes as the temperature drops. So as the ice expands, it pushes the crack apart making it larger. The process will continue until the rock breaks. Number three is exfoliation. It can happen as cracks develop parallel to the land surface as a consequence of the reduction in pressure during uplift and erosion. It occurs typically in upland areas where there are exposures of uniform coarsely crystalline igneous rock. So it is a process naman involving the weathering of rocks. Sudden change in temperature may cause cracks and fissures in the rocks. So the sudden expansion and contraction of rocks resulting in the filling up of the outer layer of rocks.
Chemical weathering. Chemical weathering. Chemical weathering affects hill slope form by directly removing mass from hill slopes. The transformation of primary minerals to secondary minerals can also affect the hydrology, biodata, and stability of hill slopes, which in turn influence sediment transport and landscape morphology. Erosion in evolving landscapes can modulate and be modulated by chemical weathering. For example, pulses of accelerated erosion can lower the residence time of hill slopes materials, thereby increasing their chemical weathering rates, which in turn accelerate the incision signal. We have presented statement of mass conservation that allow quantification of the important feedbacks between chemical weathering and hill slope form. However, many of the constitutive relationships required to solve these equations are still lacking. For example, we do not know if chemical weathering influences the efficiency of sediment transport or how it influences the rate at which soil is produced at a given soil thickness. Studies quantifying these relationships are required before we can fully understand how chemical weathering influences hill slope form and the nature of the feedbacks between chemical weathering and landscape evolution. These studies are necessary if we are to develop an integrative understanding of dynamic feedbacks between climate, biochemical cycles, and landscape evolution. Chemical weathering, on the other hand, is an actual change in composition as minerals are modified from one type to another. Many, if not most, of the changes are accompanied by volumetric increase or decrease, which in itself further promotes additional chemical weathering. The rate depends on temperature, surface area, and available water. The major reactions involved in chemical weathering are oxidation, hydrolysis, and carbonation. Oxidation is a reaction with oxygen to form an oxide. Hydrolysis is a reaction with water. And carbonation is a reaction with carbon dioxide to form a carbonate. In these reactions, the total volume increases, and since chemical weathering is the most effective on grain surface, disintegration of rock occurs. Quartz, whether vein deposits or individual grains, undergoes practically no chemical weathering. The end product is quartz sand. Some of the feldspars weather to clay and release calcium, sodium, silica, and many other elements that are transported in water. The iron-bearing minerals provide in addition to iron and magnesium. Weathering products are similar to the feldspars. Chemical weathering is equivalent to pouring acid on a rock. The residual product of weathering is unconsolidated sediment. Now let us move on to the different types of chemical weathering. The first one is carbonation. When you think of carbonation, you think carbon, right? Carbonic acid is the culprit when it comes to the carbonation types of chemical weathering. As rain goes through the air and into the ground, it grabs carbon dioxide, creating carbonic acid. This weak acid reacts to the calcium carbonate in stones when it seeps into the cracks. A stone that is particularly susceptible to carbonation is limestone, which is made of mostly calcium carbonate. Carbonation of limestone creates unique structures like the South China Karst. Karsts are all over the globe, include unique caves, streams, sinkholes, and unusual rock formations. Next one is hydrolysis. Water can add to a material to make a new material, or it can dissolve a material to change it. In hydrolysis, the acid in the water works to dissolve minerals within specific rocks. Examples of hydrolysis in action include turning feldspar into clay and making sodium minerals into saltwater solutions. The flare slopes of Australia are partly created by hydrolysis. Hydrolysis is the chemical breakdown of a substance when combined with water. It also occurs, for example, when water comes in contact with granite. Feldspar crystals inside the granite react chemically, forming clay minerals. The most common example of hydrolysis is feldspar in granite rocks changing into clay. Oxidation is another kind of chemical weathering that occurs when oxygen combines with another substance and create compounds called oxides. When rocks, particularly those with iron on them, are exposed to air and water, the iron undergoes oxidation, which can weaken the rocks and make them crumble. Oxidation is a chemical process when oxygen in the air reacts with things which are made of reactive chemicals. Oxidation is a type of chemical weathering that is why it causes things to weather or wear away. Oxidation occurs when an atom, molecule, or ion loses one or more electron in a chemical reaction. When oxidation occurs, the oxidation state of a chemical species increases. The oxidation doesn't necessarily involve oxygen. Originally, the term was used when oxygen caused electron loss in a reaction.
Biological weathering. Biological weathering. Biological weathering of rocks occurs when the rock are weakened by different biological agents like plants and animals. The plant's roots grow through rock. It creates fracture and cracks that result eventually to rock breakage. It can be classified into biological weathering by physical means, borrowing animal like shrews, moles, and earthworms, create holes on the ground by excavation and move the rock fragment to the surface. These fragments become more exposed to other environmental factors that can further enhance their weather- weathering. Furthermore, humans also indirectly contribute to biological weathering by different activities that cause rock to break. Biological weathering by chemical compounds. Some plants and animals also produce acidic substances that react with the rock and cause its slow disintegration. Thanks for listening.